This lesson 9.1, we are cruising along. Notice how happy I sound? Okay, so number one, x plus 0 equals x. This is identity. You get your identity back. 9 plus 2 times 3 minus 10. 9 plus 6 minus 10. 15 minus 10 equals 5. Okay. Today we're going to classify numbers. Okay? Each number can be classified into different groups. Each number could belong to more than one group. Some numbers only belong to one group. We'll discuss that. So natural numbers are numbers that occur naturally. They're the numbers you count with, okay? They start with 1, they go on forever and ever. So natural numbers are all positive numbers. All positive numbers are natural. They do not include 0. They do not include negatives. Okay? Whole numbers. Now we're just going to add something to this. Whole numbers are all positive numbers and 0. When you think of building a hole or digging a hole in the ground, you think of a 0. Whole numbers are positive numbers and 0. Okay. So this is 0 and positive numbers. So then integers, if whole numbers are 0 plus positives, and natural are all positives, what do you think integers go? What do you think integers include? Yeah, they're negatives, they're positives, they're 0 numbers. So, integers...
Excuse me, boss. You have a text message.
Integers are all negative numbers, they're all positive numbers, and they're 0. So if it's positive, negative, or 0, it's an integer. As you can see, some numbers can be all three. For example, the number 1 is a natural number, it is a whole number, and it is an integer. Next, we have rational numbers. This is where it starts to get a little confusing. Rational numbers are any number that can be written as a fraction. Now, 15 is an integer. I'm sorry, 15 is rational because it can be written as a fraction. All I have to do is put a 1 under 15 and I write it as a fraction. Negative 125, just put a 1 under it, I write it as a fraction. Here's where you really need to understand 1/4, this is a fraction. 1/4 is a fraction. If it's a fraction, it is a rational number. Now, here's where things get confusing. Negative 3 can be written as a fraction, so it's also rational and an integer. However, 1/4 is not an integer. Is not an integer. If it's a fraction that cannot be written as anything but a fraction, it's not an integer. We'll see that as we go on, okay? So 1/4 would be rational, but 1/4 would not be an integer. Integers are just positive, negative, and 0. They look like the numbers we have here in our example. See, all these can be written as a fraction, but they can also be written not to look like a fraction. 1/4 can only be written to look like a fraction. Now, rational numbers are also decimals that terminate. So not only can they be written as a fraction, they're also decimals. Now, you know that 1/4 is a decimal. What is the decimal equivalent of 1/4? Hello? What's the decimal equivalent of 1/4? 0.25, yes. See, 0.25 and 1/4 are the same thing. 0.25 is a decimal that ends. That's why it's rational. However, rationals can also be numbers they can also be decimals that repeat. So they're decimals that end, or they're decimals that repeat. 0.33333 with a line above it, or 0.11111 with a line above it. Okay, so rational are decimals that terminate, or decimals that repeat. They have a pattern. So 0.1256, 1256, 1256. That is a repeating decimal. It has a pattern. So it's rational. Okay. Now, irrational numbers cannot be written as a fraction. Now, I know that your math teacher in elementary school told you all numbers can be written as a fraction by putting a 1 under it, and they're right. However, unless it's irrational. If it's irrational, it cannot be written as a fraction. Square roots, unless it's a perfect square. What are perfect squares? Give me an example of a perfect square. 81. The square root of 81. What does the square root of 81 equal? 9, because 9 times 9 is 81. We're going to be talking about square roots coming up real soon. So the square root of 81 is not irrational because it equals 9, and 9 over 1 is a fraction, so it would be rational. However, 5 is not a perfect square. There are not two numbers that can be multiplied together to give you 5. So it cannot be written as a fraction. And it's going to be a decimal that goes on forever and ever, never repeats, never has a pattern. Pi, 3.14, and it goes on forever and ever and ever. Okay? Decimals that never end or repeat are irrational. So anytime you see a square root and it's not a perfect square, it's irrational. Anytime you see the pi symbol, irrational. For this class, that's the only time it's irrational. A non-perfect square and a square root, and pi. Real numbers. For this class, all numbers we work with are real. So every number we give you is going to be real. Okay? Okay, let's see how this goes. You see this little thing right here? This is our magic classifying, let's call it a pyramid. It's the magic classification pyramid. Here's how it works. When you classify numbers, let's say the square root of 3. Now, is the square root of 3 a perfect square? No. So I bring it over here because every number we deal with is real. So it starts off being real right here, okay? Now I need to determine, is it rational or irrational? Is it going to go this way or this way? So which way is it going to go? Can you write the square root of 3 as a fraction? No, so it's going to go down here and become irrational, isn't it? I'm done. So if I was going to classify this number, it would be real, irrational, okay? Let's look at the square root of 25. Is the square root of 25 a perfect square? What does the square root of 25 equal? It equals 5. So what I'm going to do is I'm going to replace that with 5 because those are the same thing. So now let's classify the number 5. Can 5 be written as a fraction?
Yes.
Yes. You just put a 1 underneath it. So it's rational. It slides down and becomes rational. Now, I keep going until I stop. Look at your classifications. Is 5 an integer? Yeah, it can be written as a fraction, but it can also be written as a number that's not a fraction. So it is an integer. Is it a whole number? 0 and positives are whole. Is it a natural number? So this gets classified real, rational, integer, whole, natural. What about the number 17 over 4? I put it up here on the slide. Can 17 over 4 be written as a fraction?
Yes.
Yes, it is a fraction. So it slides down to rational. Is 17 over 4 an integer? Put 17 divided by 4 in your calculator. What does it tell you? It tells you 17 over 4, right? So it cannot be turned into a number that doesn't look like a fraction. So it ends right here at rational. What about the number negative 14 over 2? Negative 14 over 2. Can this be written as a fraction or no? Yeah, it is a fraction, so it can be written as a fraction, so it slides down here to rational. Now, can negative 14 over 2 be written so that it doesn't look like a fraction?
Yes.
Put in your calculator. What does it tell you?
7.
Negative 7, right? So it is an integer, because it is really negative 7. So now I'm going to erase it, and I'm going to write negative 7. Now, if negative 7, is that a whole number? Whole numbers are positive and 0, so it stays right there at integer. This is how we classify numbers, okay? That's how we're going to classify all these numbers here. I'm going to skip because I want to look at number 15 for the video people. These are going to be on the test. These are going to be on the CRT at the end of the year. I have to solve this because I need to determine all the number sets with the solution belongs to. So I add 5 to both sides, get 3a. I subtract 12, negative 21, divide by 3. A equals negative 7. So what it wants me to classify is negative 7. Is negative 7 real? Yep, it's real. Is it rational or irrational? It's rational because it can be written as a fraction. Is it an integer? Positive, negatives, and 0, so it's an integer. Is it a whole number? No. So right here is my answer. Real, rational, integer. When you get here, determine all the number sets the slope belongs to, you have to figure out the slope. Isolate the y, figure out the slope, and then classify it. Okay. That's it for our online people. If you have any questions, please feel free to come in and ask.